Good afternoon to our lecturer, Dr. Muhammad Hanis bin Muhammad Nasir, and our beloved friends. So, we are students from section 36, course SSC 1993, Engineering Mathematics 2. In this video, we will present solutions for our group assignment, which covers line integrals, conservative vector fields, Green theorem, Gauss theorem, and Stokes theorems. Throughout this presentation, each question will be clearly introduced before being explained by the assigned group member, with complete steps, formulas, and final answers. First and foremost, our question 1 requires us to evaluate a line integral of a vector field along a curve defined parametrically. The main idea here is to express all variables in terms of the parameter, compute the differentials, and then substitute everything into the line integral before integrating over the given interval. Now I would like to invite Emily to explain the solution for question 1.
Hi, I'm Emily. I will be presenting the solution for question 1. For question 1, we need to evaluate the line integral x squared dx minus sin z dy plus 2yz dz, where C is the curve given by position vector rt equals to t squared I minus 2j plus sin tk for t equals to from 0 to pi over 2. By looking at the position vector equation t squared is the equation for xt, the component of j is the component of yt, and the component of k is the component of zt. And then we differentiate xt, yt, and zt with t simultaneously, so that we can get dx equals to 2t dt, dy equals to 0 dt, dz equals to cos t dt. And then we sub dx, dy, and dz into the line integral equation, and we sub x squared, sin z, and 2yz in terms of t. So after substituting finish all the line integral equation in terms of t, and we're looking at the second term and third term, it is consists of 0 terms, so these two terms are cancelled out, and finally we get integral of 2t power of 5 dt from t equals to 0 to t equals to pi over 2. And then to integrate 2t power 5, we get 2t power 6 over 6. After substituting the t equals to 0 and t equals to pi over 2, we get the final answer is 5.
Next, for the question 2, we focus on determining whether a force field is conservative. We firstly verify this by checking the equality of mixed partial derivative. Once the field is confirmed to be conservative, we find its potential function and use it to evaluate a line integral along a given curve. Let us proceed with John for question 2.
The question is given the force field. We need to show that the force field is conservative. Therefore, we need to do a conservative test, which is to find the curve of the force field. Based on the calculation, we obtain that the curve of the force field is equal to 0, which means the force field is conservative. We also need to find the potential function. To find the potential function, we need to calculate the gradient. Then we need to integrate the gradient to obtain the terms of phi. For all similar terms of the phi, we just integrate once, then combine all the phi terms in one equation. Therefore, we will obtain a phi equation which is y sin s plus z square s minus y plus z. After that, we evaluate the line integral where the c is the curve given by the vector. The vector is cos t5 plus sin tk plus tk, where the limit of the t is between 0 and pi. We need to calculate the phi equation of the highest term of the t minus the phi equation of the lowest term of the t. We will find all the values of s, y, z when t equals 0 and when t equals pi. Based on the calculation, we find that the x value is equal 1, y values is equal 0, z is equal 0 when t equals 0. We also obtain that x equals 0, y equal 1, z equal pi when t equals pi. We substitute all the values of x, y, and z into the equation. And lastly, to obtain the final answer, which is pi minus 1. That's all from me. Thank you.
On the other hand, in question 3, we are asked to evaluate a line integral along a straight line segment between 2 points. The key step is to parameterize the straight line, substitute the expression into the integral, and then evaluate it directly. I now invite Daoshen to present question 3.
Hi, I'm Daoshen. Let's proceed to question 3. I will show you the solution of question 3 step by steps. Here's the question 3. Evaluate this, where C is the straight line segment from this point to this point. First of all, we can draw a 3D diagram to see where the points are. And this is the first point to the second point. And here is the line segment between these 2 points. And we can compute the parametric equation from the first point to the second point. First of all, we need to choose interval t between 0 to 1. And we can compute also xt equal to x1 plus x2 minus x1 times t. x1 is 1 and x2 is 4. So we will get xt equals to 1 plus 3t. Same goes to yt and zt. Yt equals to y1 plus y2 minus y1 times t. y1 is 0 and y2 is 1. So we will get t for yt. For the zt, z1 is 2, z2 is 3, and we will get 2 plus t for zt. After getting the answer for xt, yt, and zt, we can proceed to the differentiation for these terms. So we will get dx over dt, dy over dt, and dz over dt. And we should move dt to the right side with the constant and leave the dx, dy, dz at the left side as the subject of the equation. Here's the last step of our solution, compute line integral. From the question, we are given the expression like this. So we rewrite the equation and we substitute x, y, and z, dx, dy, dz into the t terms. And don't forget to insert the interval between 0 to 1. So everything is in t terms and the limits are inserted. We can proceed with the integration and we will get the final answer as 337 over 12. That's all for me. Thank you.
In addition, question 4 examines whether a given vector field is path independent. After proving that the field is conservative, we determine its potential function and calculate the work done along multiple line segments between given points. Please welcome Chen Yan for question 4.
Hi, I'm Chen Yan. I'm in charge for this question 4. So for this question, I will show that a line integral is path independent, find the potential function, and evaluate the work done. To begin with, we need to do the conservative test. So we are given the vector field, which is vector f of x, y, z is equal to 6xy cubed plus 2z squared I hat, 9x squared y squared z hat, and 4xz plus 1k hat. So to check the path independence, we need to compute the curl, which is delta cross vector f. After evaluating all components, each term is equal to 0. So the curl is 0 everywhere. Therefore, the vector field is conservative and the line integral is path independent. So next, we need to find the potential function. Since the vector field is conservative, so there exists a scalar function phi such that the delta phi equals vector f. This means that the partial derivative of phi with respect to xyz gives the xyz components of vector field. So I will now integrate each component. Since the field is conservative, so all the integral must present the same potential function. So first we consider the x component. Partial phi by partial x is equal to 6xy cubed plus 2z squared. So integrate with respect to x, treating y and z as constant, so I obtain the 3x squared y cubed plus 2x z squared plus c1. So next I consider the y component. So partial phi by partial y equals 9x squared y squared. So integrating with respect to y, I obtain 3x squared y cubed plus c2. So now I consider the z component. So partial phi by partial z equals to 4xz plus 1. So integrating with respect to z, I obtain 2xz squared plus z plus c3. So since the curl of the vector field is 0, so the field is conservative. Therefore, all three expressions must correspond to the same potential function. So I now combine the consistent terms that appear in all expressions. Hence, the potential function is y of xyz equals 3x squared y cubed plus t plus 2xz squared plus z. So step 3, we need to calculate the work done. So the work done is given by work equals phi final minus phi initial. So we know that the initial point is 0, 0, 2, the final point is minus 1, 2, minus 3. So when we calculate and put it into potential functions equation, we can get that the work done is equal to 1 unit. So in conclusion, the vector field is conservative, the potential function is found, and the work done is equal to 1. Thank you.
Moreover, question 5 involves another conservative force field, this time including exponential and trigonometric functions. We verify the conservative nature of the field, find its potential function, and then calculate the work done between 2 points, which is independent of the chosen path. Let's move on to singing for question 5.
So now, come to question 5. Let us analyze the question first. Show that the force field is this equation, and this equation is a conservative field. So, what is conservative field? Conservative field means the vector f equals to 0. And then the question asks us to find the potential function and the work done. So now we will find the potential function first. First, we will differentiate the potential function with respect to x, and which will equals to exponential of x sine y. After that, we'll do the differentiation of potential function with respect to y. So we will get exponential x cos sine y. Finally, we'll do the differentiation of potential function with respect to z, which will equals to z squared. So now we will find the potential function. So we will integrate what we get from here, then we can get the potential function. So finally we will get potential function equals to potential function with respect to x, y, z will equals to exponential of x sine y plus z cubed over 3. So now we found the potential function. Step 2, we will find the work done. Formula for work done is integration of vector f with respect to r. So now we will use the potential function with respect to 1, 1, 2 minus potential function of 1, 0, 1. So now we will sub the x, y, z respectively inside the potential function equation. So finally, the work done is equals to exponential of 1 sine 1 plus 7 over 3. That's all.
In addition, question 6 apply Green theorem, which allows us to convert a line integrals into a double integral over a region. This simplifies the computation by using partial derivatives and carefully identifying the bounded region and its orientation. I now invite Jiaxuan to explain question 6.
I'm in Jiaxuan. I'm going to present about the question 6. So in question 6, we can know that we have to use the Green's theorem to evaluate the equation, where C is the boundary of a region bounded by a straight line, the semicircle, and the exit is in an anticlockwise manner. So we need to identify the P and Q first. So, and we differentiate it, and we also need to draw the graph, and we can get the region, and we need to draw two lines pass through the x-axis and y-axis so that we can get the limits. The y limit is from 0 to 2, and the x limit is from y minus 2 and square root 1 minus y minus 1 square. And we start into the Green theorem equation so that we can get the equation to integrate. So we integrate the 4x dx dy, and so that we can get the final answer, which is negative 8/3.
Apart from that, question 7 uses Gauss theorem, also known as the diverge theorem. Instead of evaluating a surface integral directly, we compute the diverge of the vector field and integrate it over the volume of a sphere. Please welcome Putra for question 7.
Hi, Assalamualaikum. My name is Putra Muhammad Faris, and my metric number is 823KA0133. And today I will be explaining about question 7, which is Gauss theorem question. So from the question, they give f x y z equals to 7xi minus zk, and the formula of the sphere is x squared plus y squared plus z squared equals to 16. So from the question, we can compute that 7xi plus 0j and negative zk, because there is no value of j here. We can compute that j is 0. And the formula of sphere here, we can compute that our radius is 4. And then we can sketch our solid circle graph, and we can compute that our radius is 4. Okay, so we can move to write our divergence formula here, which is we can differentiate 7, 0 and negative z. And differentiate of 7, we can get 7. Differentiate of 0, we can get 0. And differentiate of negative z, we got negative 1. And the sum up of our differentiate just now is 6. And our final step is to multiply 6 and the volume of the sphere. So we calculate the volume of the sphere using the formula 4/3 pi r cube, and we just substitute the value of r is equals to 4, and then this is our final volume value, 256 over 3 pi. And for the final step, we can multiply 6 and the volume. So we can multiply 6 and 256 over 3 pi. And this is our last value answer, which is 2512 pi. That's all from me. Thank you.
Furthermore, question 8 applies Stokes theorem, which relates a line integral around a closed curve to a surface integral of the curl of the vector field. We calculate the curl, choose a suitable surface, and evaluate the resulting surface integral. Let us proceed with Rama for question 8.
Hello everyone, I'm Rahma Hussein, and I will explain question 8, where we evaluate a line integral using Stokes theorem. We are given that the vector field is f x y z is equal to x squared plus y squared plus yi plus 2zj plus x squared k, and a closed curve C, which is the intersection curve between the plane z equals to 2 with the cone z equals to root x squared plus y squared, traverse counterclockwise as viewed from above. Stokes' theorem says that the circulation of a vector field around a closed curve equals to the total curl passing through the surface bounded by the curve. So instead of evaluating the line integral directly, we use Stokes' theorem, which states that the integration of f is equal to the double integration of the dot product of the curl of f with n, which is the normal vector to the surface. And since our equation says that it's counterclockwise and viewed from above, then the normal vector to the surface is equal to 0, 0, 1. And after computing, the curl of f is equal to negative 2, negative 2x, and negative 2y plus 1. And the dot product of the curl of f with n is the normal vector to the surface, we get that it's equal to negative 2y plus 1. Step 2 is to convert to polar coordinates. So we are given a curve C with the intersection of z equals to 2 and z equals to root x squared plus y squared. Root x squared plus y squared is equal to 2, which means that we get a circle equation, x squared plus y squared equals to 4. So we get a radius of 2. Now the equation that we get is the double integration of negative 2y plus 1 dA. So first we need to convert the y to a polar coordinate and dA to a polar coordinate. So the double integral of negative 2y plus 1 dA is equal to the double integral of negative 2r sine theta plus 1 or dr d theta, with limits of r between 0 to 2 and limits of theta between 0 to 2 pi. Evaluating the integration, we get that the final answer is 2 pi. Thank you.
Last but not least, question 9 is evaluate a surface integral over a plane bounded by given constraint. The approach involves parameterizing the surface, determining the surface element, and integrating over the specified region. I now invite Zebin to present question 9.
Hello, my name is Hong. So here I will present to you the question 9. So first thing we do is we analyze the question. As given, we have the double integral y plus z, and also the portion of the plane y plus z equals to 1, bounded by the planes z equals to 0, x equals to 0, and y equals to x, which will form a solid that is surrounded by multiple triangle, as you can see at the xyz plane projection. And secondly, I do the xy plane projection to analyze the equation, I mean the range, to get the range. So first I choose the analyze across the x-axis, and here I get the entering point is the x equals to 0 plane, and the exit point, I mean plane, is the y equals to x. So I just put it x equals to y. So after that, we will get the result of 0 is smaller than or equal to x, smaller than equal to y, and also 0 smaller than or equal to y, smaller than or equal to 1. So after that, we need to decide which case is this, and what equation should we choose, what formula should we choose. So after the analyze, we choose the case 1, which is we studied before in class. So at this point, you will see that I choose I write the equation as 1 times the equation, but the 1 is actually come from the y plus z equals to 1. So I just replace the 1 to the y plus z. So everything will be simpler lah. And also another thing is I put the range. First I solve the dx first, then I solve the dy. So after the calculation, I will get the cert2 over 2 lah, which is the final answer. So hope you all understand this. Thank you.
So in this assignment, we have successfully discussed and solved integral along parametric curve and straight line path, conservative vector field and potential functions, application of Green theorems, Gauss theorem, Stokes theorems, evaluation of surface integrals. These topics are fundamental in engineering mathematics, and they are widely used to analyze problems involving force, work, flux, and circulation in real-world engineering application. On behalf of the group, we would like to thank Dr. Muhammad Hanis bin Muhammad Nasir for watching our presentation. Thank you, everyone.